Hello, this is Mr. Wynn, and this is the determinant of a matrix in solving systems using Cramer's rule. This is for pre-AP only. So determinants are a unique single number for each square matrix. They tell us something very important, kind of like the true value or size of a matrix. And a square matrix is a matrix that has the same number of rows and columns. For example, matrix A is a 2 by 2. 2 rows, 2 columns. That means it has a determinant because it's square. The next one, B, is a 3 by 3. 3 rows, 3 columns. They're the same, so this has a determinant as well. This last one, matrix C, is a 1 row, 2 columns, 1 by 2. Those are not the same numbers. This is not a square, so no determinant. So it must be a square. Alright. If you have a 2 by 2, the way to find the determinant is you're going to do the downward diagonal minus the upward diagonal. And when you do the numbers in a diagonal, they always multiply. So I'm going to do the downward diagonal. I'm going to do 8 times 7. 8 times 7 is 56. Minus the upward diagonal. 5 times 6 is 30. I subtract that, I get 26, and that's the answer. Very simple. Downward diagonal minus upward diagonal. Alright, if you have a 3 by 3, very similar idea, but there's going to be multiple diagonals. But still the same thing. It's going to be the downward diagonals minus the upward diagonals. But since there's multiple diagonals, you do the sum of the downward diagonals minus the sum of the upward diagonals. You also do a little trick where you have to rewrite the first 2 columns twice to the side. So I put 8 here, 2, 1, 3, 4, 6. Alright, so I'm going to do the first downward diagonal. 8 times 4 times 5. So that's 20 times 7 is 160. Then the next downward diagonal, 3 times 2 times 1. That's 6. Then I'm going to do 4 times 2 times 6. That's 48. I'm going to add all this together, and I get 214. All right, now do the upward diagonals. 1 times 4 times 4 is 16. 2 times 6 times 8, that's 96. And then 5 times 2 times 3, that's 30. If I add those up, I get 102, 112, 142. Those two numbers I'm going to subtract. So 214 minus 142 is 72. Final answer, 72. That's the determinant there. One cool thing we do with determinants is use them to find or solve systems. So determinants can help us solve systems using a method called Cramer's rule. It's kind of long though, so REF is much better, but it's an extra option. But it basically says we can divide the determinants to solve. So given this equation right here, the system 10x minus 3y equals to negative 34, 3x plus 8y equals negative 8. I'm going to do the original coefficient matrix on the left side. So I'll call this the original. And it's going to be 10, negative 3. And then for the second equation, it'll be 3 and 8. That's the original. Then I'll make 2 more. I'm going to do the same, but I'm going to say I'll replace x with answers. So if I replace x, I get negative 34, negative 3, and then, where's the other one? Negative 28, and positive 8. Then also I'm going to do one more. I'm going to replace the y. So let me do like this. So there's that one. My third one will be replacing y. So that will be 10 and 3 for x. And to make it easier, it'll be negative 34 and negative 28 for y. Alright, I'm going to find the determinants of each. So downward diagonal, 30, or sorry, that's 80. Minus upward diagonal, minus negative 9, that's really adding, so that's 89. This next one, I'm going to do downward diagonal. Alright, if you multiply negative 34 times 8, you get negative 272. Minus the other thing, negative 28 times negative 3 is positive 84. If I subtract those, I get negative 356. This last one, 10 times negative 28 is negative 280. Minus 3 times negative 34 is negative 102. That's subtracting negatives, really adding. So that gives me negative 178. If you divide the determinants, the original x one, so negative 356, over, I'll do this, x equals, the x determinant, like you replace x over the original, you get what x actually is, which is -4. And you do the same thing for y's. Where you replace y, you get -178 over the original, 89. You get -2. So we found x and y. So the final answer is a point, -4, -2. This is consistent and independent. And that's it for the video. Hope you enjoyed it. Thanks for watching. See you in class. Bye.